Hi grade 12s, welcome to another one of our video lessons. So today we're going to carry on with Unit 3, Measuring Volume. Last lesson we looked at the health chart, measuring length and distance, and also measuring mass and working out BMIs and classifying that BMI. Okay, so today let's carry on with Unit 3, Measuring Volume. We're going to do exercise 7 and 8. And then we're going to do measuring temperature, or rather you guys are going to do those exercises. And then in the next lesson, we're going to look at other scales that we have, for example, Fahrenheit and Celsius and Kelvin, and how do we go from one to another. All right, guys, so let's start with page 172. So one important thing here to note is the conversion between liters in terms of volume of liquid to actual distances and cubic centimeters and meters, because sometimes we'll ask you convert liters into cubic centimeters and so forth. So the easiest way to think about this is that 1 liter equals to a box. If we think of a 1 liter box that looks like this, okay, which measures 10 centimeters, 10 centimeters, and 10 centimeters. Okay, so if we take a container, a box, make it 10 centimeters by 10 by 10, so it's a little cube like this. If we pour 1 liter into it, it will be almost exactly that volume. Okay, so that is our identity to go from volume of liters of liquid into actual distance volume and cubic meters and cubic centimeters. Okay, so if we work this out, what is 1 liter? Well, how do we work out the volume of this cube? It is 10 times 10 times 10, and it is centimeters cubed. So essentially 1 liter is going to be 1,000 centimeters cubed. Okay, that is our basic conversion that we're going to use. So now, then one of the questions I can ask you, I have three cubic meters of juice. Okay, into how many 1 liter packs can I put that juice into? How many 1 liter packs am I going to get? Or how many 1.5 liter packs I'm going to get, and so on. So what you need to now do is go from cubic meters to cubic centimeters, and then take that volume in cubic meters divided by the cubic centimeters of, well, 1,000 cubic centimeters, and then you'll get back to how many liters that is. Okay, guys, that's probably the most important thing from going from volume to cubic distances. Okay. All right, so if we keep that in mind, let's now look at exercise 7. So for this exercise, you'll need oranges, preferably 1 per person in your class, or otherwise 1 per group. You'll also find an orange squeezer useful, but you must have a measuring jug or cylinder that can measure quantities less than 100 milliliters fairly accurately. Okay guys, so I'm going to go get an orange quickly. I'm going to pause this video. Hey guys, I'm back. Turns out I don't have an orange, but I have a gem squash. Okay, so it's kind of like an orange but green. Okay, so yeah, if you guys have something round, then get it, and then we can use that to work through this example. All right, so they want us to get an orange so we can measure the circumference, and they want us to find the volume of an orange in a measuring jug and an orange squeezer. I think we're pushing it there with my gem squash, but look, if we need to, we'll improvise, so don't worry. All right, let's start with number 1. First, you need to calculate the volume of your orange. You'll need to know what the radius of your orange is in order to calculate its volume. It is not very easy to measure the radius, but if you know the circumference, you can calculate the radius. Okay, so they're being quite smart here, because if we look at this orange, okay, so the radius is from the center to the outside point on this orange, right, on this gem squash. So obviously we can't get in there without cutting it open, but we can go backwards. If we know the circumference, let's assume this is a sphere and it's perfectly round. If we know the circumference around the orange, we can use that to go backwards and find the radius. And once we have the radius of this orange, we can use our volume formula and find out what is the volume of this orange, so to speak. Okay. All right, so let's do that. So number 1.1, it says, cut out a strip of paper and wrap it around the widest part of the circumference of your orange. Make a mark on the strip where the end meets it, so that when you unwrap the paper strip from the orange, you can measure the length of the circumference marked on the paper using a ruler. Okay, so what they're basically saying is that take a piece of paper, wrap it around the widest part of your orange, so that's what I'll do over there. Okay, and where these two papers intersect, make a mark. Okay, so there they are. Okay, my pencil is broken. Okay, so what we're doing, we're making a mark there. Okay, so I've wrapped the paper, I made a mark. So now what we can do is when we unwrap the paper, we can actually measure what that distance is. Okay, so I'm going to take my ruler and measure. Okay, you guys can do the same, or if you've done it already, give me a sec. So that's 15, 25. I get about 26 centimeters. Okay, I'm going to round it off to 26 just so that it makes our life a little bit easier. So, okay, we have our box on the board. So we'll remember that. So 1 liter is 1,000 centimeters squared and comes from 10 times 10 times 10. Okay. So now here's our orange. Okay. And the circumference C equals to 26 centimeters. Okay. That's what we've worked out. All right, let's see what they want now. So now it says 1.2. You know the circumference equals to 2 pi r. So you can work out what the value of r is. Okay, so we know circumference is 26 centimeters. We know also that circumference is 2 pi r. Okay, so from this, we can equate circumference to be 26. And pi, we already know it's 3.14. 2 is just a 2, and then we can get our r out. So basically, we need to isolate our r by itself. So what we do is we divide both sides by 2 pi. Divide there and divide there by 2 pi like that. Okay? Now what's going to happen is that 2 pi cancels with that 2 pi, leaving us with just an r, because that's what we want. So our r equals to C over 2 pi. Okay. Thank you. Just getting a coffee, guys. All right, anyway, so we've got r equals C over 2 pi, but now we know C is 26 centimeters because we just measured the circumference of our orange, okay? So therefore, radius equals to 26 over 2 pi. Okay, and then we can put that into our calculator and we'll get the answer. Okay, guys, I don't have a calculator here, but I can simplify. 26 divided by 2 is going to be 13 over pi. Okay, so my radius of my orange is 13 over pi. Okay, you guys will probably get something else if you measured not 26, but whatever you did, you'll get a slightly different answer, but that doesn't matter. Okay. And also, I don't mind if you leave your answer like this, okay? Unless I say work it out in decimals and round off to 2 decimal points. Then you got to give it to me like that. But if you leave it 13 over pi, I'm okay with that as well, unless I specify otherwise. Okay. Right, let's continue. So we've got 1.2. 1.3. Now use a formula to calculate the volume of your orange in cubic centimeters. Volume equals 4 over 3 pi r cubed. All right, so they want volume in cubic centimeters. We are already working in centimeters, so that is okay. We don't need to convert anything to anything else. If you measured your circumference in millimeters, I would suggest convert it to centimeters so that you don't get into this trap. Guys, a lot of the time when you're writing tests, exams and stuff, the units, we will give you different units to trick you, to see if you know that. And a lot of people don't realize that. They just put in the values, work it out, and give me the answer. You guys have to work always in the same unit. Okay. All right, cool. So let's continue. What do we need? We need our radius, 13 r equals 13 over pi. Okay, I'm going to erase everything else. All right, so they want now the volume of our orange. The volume formula is 4 over 3 pi r cubed. Volume equals 4 over 3 pi r cubed. Okay, that is our volume formula. Most likely we will give that to you in the exam. You're not required to memorize these formulas. So we will give you the formulas, but you need to know how they work and what you need to plug into them. All right, so for us to work out volume, all that we need, these are constants. These are just numbers. Pi is just a number on your calculator. All that we need is this radius, and we're cubing it, okay? So all that we're going to do is we're going to put the value of our radius that we worked out to be 13 over pi into the volume formula. So we can say volume equals 4 over 3 pi into 13 over pi cubed. Okay, so now all you do is you put that into your calculator, equals, and you give me the answer. And remember, the answer is in centimeters cubed because we're talking about volume here. All right, and this radius here is also in centimeters. Okay, right, so here I'm going to clean it up a little bit. So all I can do is I can cancel one of those pi's because it's a pi cubed. So we can have 4 over 3 times 13 squared over pi squared. Okay, it's not much better at all. It's really looks like the same mess. All that you need here is a calculator. Put it on the calculator, give me the answer, and yeah. Okay. Guys, but when you answer these questions, I want to see the formula in the workings. I want to see where you are putting the value in the formula, and I want to see the final answer. Okay, there's 3 marks for this thing. So don't just look at the formula in your text or in the question paper and then enter everything on your calculator and give me volume equals 320 centimeters cubed. No, you're going to get 0 for that because I don't have proof of you doing that. Okay, so I want to see the formula, substitution, and the answer. All right. Okay, cool. Let's continue. So now 1.4, express the volume of the oranges in milliliters. Remember that 1 centimeter cubed is equal to 1 milliliter. Okay, so remember 1 liter was 1,000 centimeters cubed. How many milliliters do we have in a liter? 1,000. So 1,000 milliliters equals 1,000 centimeters cubed, right? Which means that 1 milliliter equals to 1 centimeter cubed. Okay, 1 milliliter is 1 centimeter cubed. Okay, so if they want us now to express the volume of the orange in milliliters, okay, we've already expressed the answer in centimeters cubed. The ratio of milliliters to centimeters is 1 to 1. Okay, so simply to answer the next part of the question, we can just say, well, whatever answer we get here, we're just going to say, well, that equals to the same answer. Actually, you know what? I'm going to rub out this thing. I don't like it. So we'll leave this as centimeters cubed. Okay. You guys work this out and you have an answer. And then to that, we're going to say, well, it equals to the same answer, 4 over 3 pi into 13 over pi cubed milliliters. Okay, because 1 milliliter equals to 1 centimeter cubed. Okay, so that is 1.4. Right, let's look at number 2. Cut the orange in half and squeeze out the juice into the measuring jug. Read off how many milliliters of juice you squeezed out and convert your answer to cubic centimeters. Okay, so now they want us to go backwards. So we've cut our orange in half, we squeezed it out, we now poured it into a measuring jug, we see how many milliliters it is, We're now converting it back to centimeters cubed, which is again the same value because the ratio is always 1-to-1 between milliliters and centimeters cubed. All right. So convert your answer to cubic centimeters. Okay, so we've done that. Okay, guys, obviously my orange is non-squeezable and I cannot do this, but you guys are more than welcome to try this. If you have a measuring jug and an orange, cut it open, squeeze it, see what you get. Let's look at number 3. What percentage of the volume of the orange was juice? What percentage of the volume of the orange was juice? Okay. Remember, we worked out the volume of the orange was this much milliliters, all right? The whole orange, how much volume it would take up if we dunk it into a bucket of water, how much water would get displaced out of the water. So that's the whole orange. Now we squeeze the juice out, say we get, I don't know, let's say this answer, okay, let's see what this answer would give us. Maybe for, I don't know, maybe how much is an orange? 100 milliliters? I mean, a mug is about 200 mils. An orange is maybe 120 mils, okay? So let's say you get the volume of your orange 120. You squeeze out the juice, you only get 60 or 70, mils of juice. Because remember, in the orange, there's also gaps and air, and it's not just filled with like a whole volume of orange of juice, okay? All right, so what percentage of volume of orange was juice? So to find out percentage, okay, remember, easy. We say, I'm just trying to find my whiteboard duster. Here it is. Okay, so percent juice equals, okay, how much juice did we squeeze out in our cup? Okay, let's say we got 40 mils. Okay, maybe we got more, maybe we got less. I don't know. I haven't squeezed an orange yet. So 40 mils out of the total volume of the orange. Let's say we worked out that big value, whatever it is. You guys are going to use your answer. I'll assume it's 120 mils that the whole orange was. Okay, and then to convert to percent, what do? We multiply by 100. Okay, so that equals to 40 divided by 120. Well, that's going to give me a third. A third times 100, well, that's going to be 33%. Okay. Or 100 divided by 3 is 33.3.3, or I mean 0.3333 recurring percent. Okay. So I'm happy with 33%. Okay, it's probably more than that. But actually maybe not. I mean, I've squeezed oranges before and you don't get a lot of juice. You kind of like squeeze 5 oranges and you get a glass of juice and you're like, what? Anyway, all right, cool. So let's continue. Number 4, collect all the class's answers in question 3 and write them all up on the board for everyone to copy down. All right. If you guys want to do that, we can post that on our Skype group, your answers for the volume or the percent of the juice that you got to compare. Number 5, calculate the average value of the percentage of the volume of an orange that is juice. Okay, the average value is the mean. Okay, remember we did this before we went for our lockdown, while we still had school. So the mean is the average. So let's say there's 10 of us and we recorded different percentages, 30, 45, 15, whatever it is, right? So to find the average percent juice, we're going to add all those observations together and divide by the total number, which is 10. Okay, and that will give us the mean of percent juice in oranges. Okay, so you guys can do that. All right, and number 6, somebody tells you that they obtained 50 liters of orange juice from squeezing 100 oranges. Is this likely? Explain your answer using a calculation. Okay, so no, this is like ridiculously unlikely. Okay, firstly, we know that an orange is only about 120 mils. Okay, 150 mils. Okay. If we assume the whole orange is just juice, okay, and we have 100 of those oranges, okay, so 120 milliliters of the whole orange's juice. Let's say it's maximum juice, okay, which is probably impossible, but let's make that assumption. 120 mils times 100 oranges would give us 120 milliliters. If we divide that by 1,000 to convert it to liters, we'll get 12 liters of juice. Okay, so can he get 50 liters of juice out of squeezing 100 oranges? I don't know. It seems very unlikely because the assumption here is that we are taking the whole orange as juice, which is unrealistic, and we know it's not. And from our experiment, we know it's less than that. And also, I mean, how big are his oranges? You know, for us to go from 12 liters to 50, that's almost times 4. So we're not talking about normal oranges like this. We're talking about oranges 4 times the size of this, and the whole orange must be juice, which is really unlikely. So is this guy correct, or is this likely? No, he probably made a mistake somewhere. He probably gets 5 liters of juice, not 50 liters of juice. Okay. All right, guys, so that was exercise 7. That's how we're going to deal with volumes and so forth. So I've run through the exercise. You know what to do. Now, exercise 8 is looking at a very similar problem, but instead of now working out volume of an orange, we're working out volume of building materials and wheelbarrows and things like that. The idea is exactly the same. So your 1 liter is 1,000 cubic centimeters, and that's what you're going to use to convert your volumes. Okay, guys, I want you to do exercise 8 for homework, and the next section we're going to get onto temperature, which is unit 4, and we should finish that entire section in the next lesson, and then you'll have the blue revision section to do for homework. Okay, cool, guys. I hope you enjoyed it. I hope this made sense. Please work through this. It's an important section in matric. They'll definitely ask you questions like this in application. And yeah. All right. Cool, guys. I'll see you in our Skype lesson and in our video lectures. Bye.